Continuing on in our series of videos regarding solving trig equations, we're going to look at some actual problem solving and modeling stuff, some real stuff, fairly real stuff anyway, and where we can apply. So make sure you've watched the previous videos before this one. And we've got a little scenario here. We've got a common sort of scenario of these sort of equations. We've got water depth. So water depth in meters in a marina is modeled by a given function there. How convenient. But anyway, we've got T is the number of hours since high tide. So high tide is our reference time. So T is the amount of time since high tide. So we've got the question at what times, plural, over the next 24 hours is the depth 13 meters. So we have an implied domain, well, very implied. The domain is going to be between 0 and 24 hours. So I like to use a process in my problems which involves basically the steps highlighted in yellow: predict, clarify, solve and reflect. Now when you get to reflect, if something's not right or the answer is not reasonable or the answer can be improved, you might need to iterate, as in repeat, or repeat there, depending on what's going on. But you do need to predict what processes are involved and what the answer might look like, which we've kind of done already. We're looking at times of day. It's got to be between 0 and 24. Clarify, what does the problem need, which we're going to do in a minute. Solve, do the math, and check our answer. Does it seem reasonable, and have we had to make any assumptions, and what are the implications of making those assumptions? The graph, you can see the edge of here, which I'll reveal in a moment, is a bit of a mixture of the predict and the reflect. It's used in both. So we can predict what we're likely to get by plotting the graph using technology first. So you can do this on something like Desmos or your graphics calculator. So you can see that I've plotted the given function and also y equals 13. Actually, that probably should have been called d equals 13. Desmos is so forgiving, it forgave me for putting the wrong symbol in there. It still knew what I meant. So you've got 13 is because that's going to be a constant function there, so we can look at the intersections. So do this first would be my suggestion if you have this technology available. It doesn't do the maths for you, but it enlightens you about what to expect. So we've got time going across and we've got depth going vertically. And so 2 hours after high tide, 10 hours, 14, 22. Now we've got some other values. In fact, that'll keep going, but just remember that at 24, that's the end of it. So this one here is too far, and so is that one. So we know what to expect. Okay, so it'll be 13 meters at those number of hours after high tide. So let's do the math. So with our equation, we're subbing in 13 for our value for d, because that's what we want to know about that. We're going to use substitution and write the equation out. I'm going to put the pi on 6 separate to the t. It's different to how it was written because that's our value for b, which we've seen in previous videos, and there's a plus 11.6. So once we've written the equation down, we can do some rearranging. And so what we're expecting this to just be a regular trig equation where we're going to have to rearrange. We're going to have to make a substitution because it's got a b value. We're going to solve and then unsubstitute, if that's a word, unsubstitute, and then we're going to generate solutions because there are more than one solution. Now we know there are more than one solution, there are multiple solutions, because it says times here. We saw on the graph there, and our understanding of trig equations, they usually yield multiple solutions. So subtracting 11.6 from both sides, and we've got 2.8 cos pi on 6t, and then dividing by 2.8, and you get a half equals cos pi on 6t. Alright, so remember we have a b value here, so from what we've learned previously we need to make a substitution. Let's do that. I'm going to choose to use the symbol x, so let x equal pi on 6t. Note that that will later on mean that we've got t equals x over pi on 6. X over pi on 6, and that can be simplified as 6x on pi, or 6 on pi x. That'll be handy very soon. Okay. So updating that, we therefore, after the substitution, have half equals cos x. Let's look at the unit circle. We've got, if we look at the inverse cos of a half in radians, okay, we are in radians, okay, because of the pi. Most of these problems are worked in radians, okay, radians. Please note we're in that, and most of these questions use this unit of angular measure. So the inverse cos of a half is pi on 3. As far as our exact values go in the first quadrant. So we know that cosine is positive in the first and the fourth quadrant. See, it's positive. You can see the cosine value is positive. So we're looking at quadrants 1 and 4. So we have a pi on 6 there, pi on 6 there. No, it's pi on 3, sorry. Pi on 3, sorry, and pi on 3 there and there. So let's work out the actual angles. So obviously we have x equals pi on 3, but we also have x equals 2 pi. So 2 pi take pi on 3, so that's 5 pi over 3. That's a 5 pi over 3. So in the first revolution it's pi on 3 and 5 pi on 3, but yeah, that's not a very good 3. But of course, as we go around, we've got to check for more solutions. So it's plus 2k pi, where k is an integer. Okay, so now we need to sub back in terms of t. So since we have our substitution here, we've got, let me fix that up. We've got t equals 6 on pi x. So to get t, we've got to multiply by 6 on pi, so that would mean that we've got t. You could maybe do this in your head, but if you can't, follow this. So we've got a time to get, you can see it there, to get t we've got to multiply the x by 6 over pi, which is just a number, a real number. So you could put it out the front if you like, and we're just converting back. So you might need to take, depending on how you're traveling, you might need to take a bit of care of this step here. We do it for the other solution. X equals 5 pi over 3. Okay, and we've got 6 plus 2k pi. We've got to put our six on pi out the front there, and you can see that there. So now if we look at it's basically a distributive rule job. We got pi's cancel out, and 6 over 3 is 2, plus we got pi's cancel out with the second term there, and 6 times 2 is 12 with a k on it. And we've also got on this one here, the pi's cancel out. You've got 30 on 3, which is 10, and then we've got the pi's cancel out. 6 by 2 is 12. That makes sense, 12k, because what do you know about tides? Seems reasonable, doesn't it? They're more or less a 12-hour cycle if you know a little bit about them. So we've got, in hours, we've now got two expressions to generate our answers: 2 plus 12k hours and 10 plus 12k. So setting k equal to the integer amounts, k equals 0, k equals 1, k equals 2, it's going to make me scroll down, k equals 2. Alright, so we might not need to go that far. We'll see how we go, because remember, the domain for this, perhaps I should have written this clearly at the top, but t is between 0 and 24 hours inclusive. So it's obvious that when k equals 0, t equals 2 hours. Oh look, I've been writing x there. Nasty. Get rid of that. Sorry, they should be t's. And I will fix that. Apologies. And t equals, when k is 0, t is clearly 10. And when k is 1, we have t equals 12 plus 2 is 14 hours, or t equals 10 plus 12 is 22 hours. Now we're getting pretty close to the edge of the domain there. If we had another 12 on there, we're going to be beyond 24. So both values for k equals 2 are outside domain. So they're too big. We reject anything beyond that. That's a bit like what we're looking at the graph at the top. I said there was a couple, like 26, you might remember, was outside of the domain. Therefore, the times are t equals 2, 10, 14, and 22 hours after high tide. So write a statement to communicate after high tide, it should be, and then you can confirm using technology, and then you demonstrate that if possible with a screenshot or a sketch from your graphics calculator or Desmos or something, and confirm with tech. Well, like I said, that's done up here, and look, we got the same values. We got 2, 10, 14, and 22. Okay, and if we go down here, we get the same values. We get 2, 10, 14, and 22 after high tide in hours.